asked is, so what? What does this mean? We got an answer. It matches the back of the book answer. It matches the one I got up here. Big deal. Who cares? What does it mean to you? So let's go back to the beginning. What were we trying to find? The slope of the tangent. At what point? Any point. Any point. Okay, so what we're going to do here, I'm going to write it down here again. And -1 divided by, I'm going to leave it in this form. And let's take the inspires. Two things I want you to be able to do. I really like to only grade papers that have correct answers. Can you believe that? Okay? Much easier if you all have the right answer. Now, I always check your work to make sure that your work leads you to that correct answer, but it's nice to know ahead of time. If you don't have the right answer, you're going to go back and check your work. So let's see here. Go to new document, which we did, and let's pick up a calculator. And let's go through and let's define. It's going to make it probably a little easier on most of our work if we define. And we're going to define a function. Now, the function we were looking at was 2 divided by the square root, so we're going to say f1 of x equals and I need a fraction, and 2 divided by square root of x plus 1. Okay, so now I can do a graph if I want to, or do a bunch of stuff. What I want to do, I want to check the answer we got just to make sure. So go to menu. We haven't been here before. Some of you might have on your own been investigating. Go to menu, and you see under menu you have this thing called derivative. Isn't that nice? Derivative. Now, we haven't talked about the notation yet. We're going to get to that. But when we have a derivative, this is using a notation. It's not using f prime. It's using another notation, and we can explain that later. But down here where it's blinking, you put the input variable, because we don't always use x. So ours is the derivative with respect to x, tab. And in here you put the output expression. Okay, you put the function. What is the function's value? We could retype 2 divided by the square root of x plus 1, or we can be lazy and type what? f1 of x. Okay, which is what I'm going to do. You can retype it if you wish. Notice that when I type f1, it knows it has a defined value. When you press enter, do we get our answer? Man, I love that. Okay. I love that. Now, let's suppose you don't have it. Let's suppose you don't think of our answer as being equivalent to this. Let's put this in and let's compare it. And this is something else that you can use your inspires for, and I really want you to do this. Let's go up, pick up that answer. In other words, go up and highlight it, press enter, bring it down to the next line, and press equals. And we're going to type in the answer that we got. Okay, so we need a fraction. And we have a -1, and we divided that by x plus, was it plus 1? Yeah, x plus 1 times the square root of x plus 1. Now, this one we'll have to be a little careful. We're dealing with square roots and so forth. But what I want to see, I have a favorite 4-letter word, and it's spelled T-R-U-E, true. If those answers are equivalent, we'll see the word true. Does it come up? Mm-hmm. Oh, yes. Okay. So I don't have to have the answer the back of the book has. I don't have to have the answer that the web assign shows me. All I have to do is to know that I did my work algebraically correct, and my answer is equivalent to their answer. They may carry it out more algebraic steps. That's okay, and especially when we get into the rules, the product rule, the quotient rule, the composite function rule, all of these things, you're going to appreciate knowing how to do this, because I'm not going to ask you to carry your answer all the way to the answer the book has. And I've spent 20 minutes of my own time trying to resolve an answer that I'm happy with for you guys to the answer the back of the book has. And that's all I'm doing is Algebra 1 stuff. And so it's like, no, we're going to move forward. We're going to keep talking about calculus, not just always trying to do the factoring and do the distribution of negatives and so forth. Okay, so two things we've done here. I've shown you now this, how to get the derivative value. Okay, you can use that on the quiz, but it's not sufficient just to press that button. Okay, you have to show me all of the limit process. I've also shown you how to compare your answers. Okay, you put the answer that you're given, and you equal to the answer you have. And if it's right, you'll say true. If it's not right, now this isn't fail safe here. Sometimes I've had problems because of maybe the nature of square roots or whatever that I don't get that true coming up. And but usually if it doesn't come up with true, it comes back with the same expression that you typed in. It means that there's an error someplace. So it always prompts me to go back and be certain about my algebra. Okay? So there's just a little hint on how we can use this. Okay, now, again, so what? I've got this answer. What does it mean to me? Okay. It's the slope of a line tangent to the curve at a point. What point do you want to choose? Good. I like that number 2. Okay. We'll put 3 in here. And so this would be -1 divided by 3 plus 1, the square root of 3 plus 1. That's -1 divided by 4, the square root of 4. That's -1 divided by 8. So what? Graphically, how can we prove this? What would I want to see on a graph?
Plot the original one, and then you do the point and put the segment or the tangent line and plot it on that and go to the things with the equation next.
Okay, so we've got a few steps in there. We got time. I want you to do that. I'll be around to help you. Again, if you don't want to do it on Inspire, that's fine. Do it on your own piece of paper, but be sure you have all the information that we need. I'm going to pause this. Let's do that. Okay, so we're into the, I'll just repeat myself for the sake of the recording. We're looking at this, this problem, and we want to find the equation of a line. We need the slope and a point. The tangent's parallel to this line. We know that we have then the same slope on parallel lines. So we're just going to have to, rewrite this into the form that's going to help us. And again, I'm not going to spend a whole lot of time. Now double check me on this. I just did a couple of things in my head. Should be minus there, shouldn't it? Okay. I thought there was something. I had a sense that something was wrong. How's that now? Because if I add y to both sides, I would then have the same thing. Okay. So I know that the slope of our tangent is going to be 3. Okay, now, I don't have any more information. I don't have a point, and I don't have any more information. However, if I look at the derivative of this function, and I set that derivative equal to 3, I will then have an input. Remember back here, this came up to be another function. And if I knew that this was equal to 3, I would say equals 3, and then I could solve for x. That's going to create what on our problem here? It's going to give me that point I need, isn't it? Okay, so I've got a plan. I got a plan now. So we got to go through this. Limit delta x approaches 0. Again, always write this out because you won't forget it, and you'll have the confidence on the test that you know what it is. Okay, so we've got the derivative specifically for our problem. And let's see. I know delta x is down here. I know f of x is x cubed minus 2. I'm going to put that way over here. X cubed plus 2. And I just have to evaluate what is f of x plus delta x. Very good. I saw that, Kaylee. You're absolutely right. Did you mean to say this? Absolutely, I could tell. Okay, good. Good job. Now, here is where, you know, most people don't have the algorithm in their head to cube a binomial. So use your inspires to do that. Do you know how to do that? We did it once before, didn't we? You go to algebra, go to menu, go to algebra, go expand. While you're doing that, I'm going to go ahead and write it down because I do know the algorithm for it.
Do we have to substitute y and delta x?
Yeah, don't do y, do an h. Do an h. And then as you finish this up, just remember, don't forget to distribute all the way through that binomial. Yeah, Nash?
I'm not expanding, just keep writing x plus h.
Did you put a comma x there? Let me see what you've got here. Let me see if I can look at yours. And I don't know which one is yours here, Nash, so you'll have to kind of help. Okay. Is it this one?
Yeah.
Okay, I can see already. Do you see how you've got a parentheses out in front of the whole thing? You need to remove one set of parentheses. Yeah. You want okay, go back and put expand. Don't put parentheses first. Just yep. We don't need this set of parentheses right here. Okay. Yeah, we got a little bit of trouble here, don't we? Up at the screen, this person's on the right track, but now you got to put then another set of parentheses inside. You know, expand comes with its own parentheses. Now we need another set of parentheses in there. And so let's see if I can show you an example here of one that's correct. Yeah, this person here, you need to put another set around the x plus h. The first set is just by nature of, yeah, do this exactly, but just take away the outside one there. A little more difficult than I thought to get those. This is, okay, down here, this is exactly correct. Come on. There we go. This is exactly correct here. Notice that there's not a parenthesis out here. Notice that there's another set of parentheses inside the expand parentheses. And when you do that, it will expand it correctly. Okay. So if you do that, we've got this going on here. And let's see, at this point, when you remove all those parentheses, what do you have to be able to do? Kevin, what do you have to be able to do? Are you asking or telling me? Good. What can you cancel out? Look at the numerator.